Hi everyone, my name is Antokhina Julia, and today I welcome you on my tutorial Testing for Data Science. I graduated from Moscow State University and currently I am working at Mobile Telecommunication System in Big Data department, and I am working on recommender systems. Feel free to contact via email if you have any questions after this lecture. Today I'll be talking about testing. Testing is not the common thing in data science, and many data scientists don't do testing. But I'm here to talk about testing and say that it is easy and very useful thing. First of all, probably you are doing testing right now. Maybe you are printing your variables, maybe you are making some asserts, and code review is also a type of testing. As you can see, when you are finding some mistakes in your coworker's code, you can write it in code review, and this is testing. But it's manual. And the problems of manual testing is that cells in Jupyter notebooks can be mixed in order, and the main problem about testing is that failure stops your testing. Thus, it's not convenient to make testing automatically for hundreds and hundreds of tests. And here we start to talk about automated testing. There are different types of tests: unit testing, integration testing, and a lot more. And I'll be talking about unit testing. Unit testing refers to easiest type of testing. Then you test separate chunks of code, like functions. And integration testing is rarer type of testing in data science. It's about testing the whole pipeline. For example, your notebook with the whole pipeline. What are the reasons data scientists don't test? First of all, many people say that it works well enough without it. But that's not true. When you're starting code review, for example, you're finding out that your code have a lot of errors, mistakes, small and bigger ones, and you find them, fix them. But what if nobody looks at your code? Then these mistakes goes to production. That's not nice. Second reason is that people say they don't have time for testing. They have limits in time by business requirements. Their manager wants them to make prototype faster, and they say, I don't have time, I will make a prototype and then another one. The code will not be reusable, thus it's okay. So where can we find time for testing? First and easiest one is to test your code while you are writing it. It's very easy because you understand the whole logic of your functions, and then you can write tests to this logic. Second convenient way for testing is test your code before refactoring. Because when you refactor your code, by refactoring I mean changing the code without changing its functionality. For example, you renaming variables, or you're changing some structure, or you're making it more optimal. And before refactoring, you should write tests, because how will you know that you refactored your code well without making any additional mistakes? Testing helps you. And the other time you should write tests, and at the time you are fixing some mistakes. You can be sure that your colleague or your coworkers will not make these mistakes again, like you. Very famous concept about writing tests and the time for writing tests is test-driven development, which means that you first writing the test and then you write code. These concepts doesn't work well in data science, so I don't recommend you to use it in data science. Last but not least reason is just ordinary laziness. People may think that start testing is a very tough task, but I say that testing is very, very easy, and I'll show you today. Now, 2 advantages of testing. First advantage is that you're becoming more convenient with your code. For example, in Python, there are a lot of unlogical things in which you can make mistakes, like the example on the picture. But Python is very easy to write language, and almost all data scientists use it. But it may cause a lot of errors, so you need to test. The other advantage of writing tests is that then you're writing your tests, your code becomes more clean, because when you're writing your code for testing, it becomes shorter, cleaner, more obvious, and for spaghetti code, it is very hard to write any tests. By spaghetti code, I mean unmaintainable or legacy code, which is easy to read or very hard to read, hard to understand, and it's very tangled one. There's a fun theory about programming in spaghetti code, pizza code, ravioli code. You might Google it. Very fun. These are anti-patterns. So, moving to what exactly we are testing. In data science, there are different types of tests which fits well. First one is functional test, when you test the result of your functions or classes. Second one is non-functional tests, when you're testing performance of your code. For example, your manager says that your model should be very fast, thus you need to test how well it performs. Other testing target is model performance. When you're retraining your model, the distributions of your scores may differ a lot if something works not good in the features, and you may test it as well. And the last one is reproducibility. This is more refers to integration testing, but you can check it by, for example, making run node to your Jupyter notebooks. So next we are moving to practice. We'll be talking about testing frameworks. You can find slides and examples for this lecture on GitLab via that link. What testing libraries will we use? We will use PyTest, Hypothesis, and Faker in examples, but there are a lot more. First testing library, well known in Python, is unit test, but it has limited diagnostic and it has object-oriented interface. Other useful library is doctest, but we don't use it in data science testing because it's not very convenient to write your test in docstring. And there will be a slide about coverage. It's very easy library. I'll tell you about it later. So to warm start, I'll show you a demo of Faker library. Faker is unusual library to start with when we are talking about testing. because it's not so well known as PyTest, but it may be usable as well because it creates a lot of fake data and helps you to test the code which is used for user interaction. So first you import faker from fake, and then with this object you can generate plenty of different types of objects, variables, texts. For example, you can create Python dictionaries, different types. You can create iterable objects. I'll show you it in action. As you can see, it differs every time. Then you can also create a list and different user data. When you are creating the data, you can create pandas data frame from this fake data and use this data frame for testing your algorithms. And these are capabilities of this library. You can see the name, mail name, company, business words, country, city, and many other. For example, a phone number. There are Android platform for technical testing, different geo coordinates, texts. And this library is also capable to make tests in different languages, for example, in Russian. This is the same code, then you're creating your object with refer ru for Russian, and it creates the Russian text. Different every time. So this is all demo for Faker. As you can see, it's a very easy one. Next, we'll move to very well-known libraries, Pandas, NumPy, and Matplotlib. They have all three in common, one thing, testing. They have models for testing. I'll show it later in examples. There are other types of testing different than just ordinary unit testing. For data science, is very nice to start data testing. While you are testing your data, you can check column names, column data types, nullability, bounds, distributions, and a lot of different options. You can inspire this thing by looking at the library Great Expectations or write your own tests using PyTest. About organizing your tests. You are writing models, and to these models you are writing the test. It's convenient to have the folder tests in your root, which contain the tests which are named after the model names. Like when you have the model preprocessing, the test will be in the model test preprocessing. As for coverage py is the package which shows you how many lines of your code executed during your testing, as you can see on the picture, which doesn't show how well you tested, but may help you to check wherever you tested all your lines of code or not. But it's not necessary to test all your lines of code every time. Now we are moving to the main framework of testing in Python, refers to data science, it's PyTest. You run PyTest in command line, and there you can see how it runs. You can see that there is a virtual environment called event_example27. We run PyTest with option tracing by false, and we can see that there are some items which collected. Every item is a test, and there are statuses for them. 2 examples are failed, and 4 examples are run well. You can see the version of Python, version of PyTest here, and the result on the line down below. And this is the general interface for PyTest, and you can easily check how many tests failed and how many runs well. And now there will be a little demo for it. So about these examples, they will be in Russian, but in GitHub you will find it in English. First of all, about PyTest interface. PyTest has a naming convention that it thinks that tests are models which named with test in the naming, or the test classes which are named with test with capital 1 in the naming. And for functions, it also refers to functions which have test in their naming, like on this text. With PyTest, you can run folder, one file, or one function. These are the interface for choosing different types. While you are writing your tests, for positive ones, then you're checking that, for example, the output is right, you're using asserts. And for negative tests, which are checking that it catches right errors, you're checking it with PyTest raises. As I showed you previously, there are different types of tests. Which are here. You can see green dots for right tests, but there are many other options. You can see small s, which means that test was skipped. It may be skipped, then you're marking your function, testing function, with decorator PyTest mark skip. And when you're writing a reason for why you are skipping this test, and have maybe different types of rules for skipping that test. For example, you're developing a new version of your library, but it has very new tests which are not suitable for running the previous one, and you may mark them as if the version is lower than, don't run that test. These are for skips. Different types of marks is F, red F for failure test, capital X for negative test failure, error for some error, for example, typing errors and other types of errors, which are not referred to the test itself. You can run PyTest with different flags, and you can mark your functions also with decorator to run different functions. For example, you can mark some functions as long tests, which takes a lot of time to run, and some functions as short check. And you may decide whether you want to start small check or the longer one. Also, very useful options are verbals for typing more information. you run PyTest -v, and it shows a lot more information. As you can see here, we can see only dots, and here's the whole status, the name of the function, you can type also -q for less information. Only dots. You can type collect only for collecting your tests, and you should use this option when you are choosing site test by marking them or any other types of marking. And you may want to check which tests will run, but they're not running actually. And you can also type trace by min_no. Two types of choosing the tests you are running is marking it or typing -k and then the part of the name of the test. You can also use logical OR and not in this marking. There are other useful options. For example, you may want to show local variables. You may want to start with the test which is failed last to make your testing faster, to faster see what the test. Maybe you are starting with PyTest -q, then you see that one test is failed, and you are restarted again with lf flag. And PyTest stores information about previous run, which tests were running, which are failed, which were successed. You can also check available fixtures, but fixtures I'll tell a little bit later. So there are two different types of fixtures which are doing different things. First type is fixtures which are decorator for your function. And the second type are fixtures which are like a variable but helps you to put a complicated variable in your test. For example, you're creating pandas data frame, you're making it a fixture, and then you can use it as a variable in your tests. For fixtures, there are different areas of view. The lowest one is testing function, then goes class, model, and the biggest one, the session, means the whole testing session. And for decorator fixture, you may run it. For example, you may count the type for what every test is counting, or you may want to count what it takes for the whole testing session to run. When you should use a fixture decorator. And for fixtures for data, you may store them in a special file named conf_test.py, which is stored in a root folder of your tests. And you don't have to import it every time in your test models, because it's a special plugin of PyTest. These are the interface for fixture. This is interface for fixture, which is inputting data. And this one is for fixture, which is a decorator of your function, session, class, or model. As you can see, there's a special word for separating these two types of fixtures. And the fixture which use fixture is also a fixture. There are different types of fixtures in PyTest, which are included automatically. Tempdir is for creating temporary folders, which should be deleted after your test session. Capsys is a fixture for capturing standard input and standard output, or standard errors. And doctest namespace is a fixture for importing different types of lines of code in your doctest, but while we don't using it in data science, you may skip it. Now to writing tests workflow. When we are starting writing tests, we can start to write it in Jupyter notebooks, especially when we are studying. For example, we are testing this class. It transforms some columns into pandas using pandas to numeric, and looks very simple. Like, what errors can we find there? When we run this class and start to find different examples of using it, we're creating a small data frame for testing. And when we use the transformer, we can check pandas to numeric code with getSource to check what this means and different arguments of this function. After reading it, we move to checking data types of this data frame. And as we can see, the data types in input data frame and transfer data frame are the same, which is error, because from the start, data frame has different types. And this function, it's not only transformed your data frame and return transformed one. It also that transformed input data, which is not nice, because you don't think that this function will do two things: transforming the input and making the output. This is the error. And this is the workflow for which we are finding a lot of errors while we are testing. Now we are writing some asserts for this test. Asserts are just a line where you are writing some logical rule. We are checking the transformer mixing, and then we are rewriting this class. Now it makes a copy of data frame, and we continue checking it via testing. Running that class, fit transform, check output, check input. Looks nice. And we are writing all asserts into one function. And when we are running that function, there are no errors. And this is the format for testing functions in PyTest. You just need to export this function into module, and then it will be possible to run it with PyTest automatically. You can also run PyTest in Jupyter but it's not the nicest interface, and it's not colorful. And yeah, you can run PyTest in Jupyter, but more convenient and more right way to use it is by running it in command line. Next, we move to using fixtures. When we should use fixture? Let me explain. For example, we are creating a data frame, checking types, and after that, we'll be testing this function to numeric nonce. We are checking the previous error for copying data frame and see that input and output have different IDs. So it works. We are running that transformer. Looks nice. And when we are running test to numeric nonce transformer, it also looks well, but it's not convenient to write this example every time, but it works. And you can store this data frame as a fixture in conf_test.py. Here are two fixtures for getting data frame and getting expected data frame. This one should be transformed and the result should be as expected. And you use it by just adding as an arguments to testing function. You don't need to download it, import it separately. It works right from the scratch. And here is assert from pandas testing model. If you're checking the differences between different pandas data frames, it's better to use checks from special model, because while there are a lot of errors, if you're using ordinary assert, it will only show you that these data frames are different. And assert frame equal will show you exact lines in which there are errors. So it's better to use special testing models in pandas, numpy, and matplotlib. For example, in matplotlib, you may check that the output pictures are the same. And in numpy, you may check that your data is not the same, but very, very close. This is for fixture and testing in pandas and numpy. And next we are going to parameterize tests, which helps you to write your test shorter and cleaner. We'll test a function, field list function, which is choosing columns to work with from data frame, and has also parameters ignore case and drop mode. As there are 3 parameters for testing, you may find out that it's very hard to write a lot of tests manually. As on this example, we're creating data frame, short one. Test one parameter set, it works well. Then test another parameter cell, which is also works. And another. And after that, we suddenly found failing example. And another one. So for testing this function, we need to check all these variants, which is hard, and not the best way to doing so is to just copy paste the code with different parameters. And this is the case. There you can run parameterized tests. And this is also a nice argument for writing clean functions, which has not so many arguments, and they are easier to test. But then it's needed to have many arguments. You may run parameterized test. The interface for it is on the screen. This will be the test which is written manually, and this is parameterized version. So as you can see, you are running the whole bunch of cases. You can also mark parameters as a variable, or like this. This will be the same. And of course, you can store it as a fixture in conftest.py file, which will be the best way to run parameterized tests. And your function became a little bit shorter. You can also parameterize not only functions, but classes too. On the slide, you can see also useful fixtures for checking your time in the session or checking the time of test duration. There are a lot of more cool stuff in PyTest, for example, mocks. You can mock database connection, and the fixture are the thing you're using, for example, for Spark session. These things substitute your connection or session or any other data with some static data, and it helps you to test your function in isolation. If you want to read more about these things, there is a nice book, but in practice, all things that I mentioned is quite enough for testing in data science. And we are not using mocks as well. Other useful tools for PyTest are PyTest debugging plugin and two types of PyTest formatting if you want to auto-format your code. And we are moving to a very interesting theme, automated testing. Here I will tell you about hypothesis library, which helps you to write your tests automatically. The difference between the example which I showed in the beginning of this lecture, when you are writing your test manually, and the difference between this and PyTest is then PyTest runs your test automatically, and a hypothesis is writes your test automatically. It works by brute force search for failing examples in your tests. It knows a lot about Python features and corner cases. It also supports map, and it is ideal for working in the wild. Then a user is typing some input in your program. You can also use it in data science as the tool for checking your models and output distributions. You may check if one feature will fail. How will model work? For testing with hypothesis, you need to write the strategy in which it will generate your examples. The common strategies, there are 7, helps you to write perfect tests, which will automatically find corner cases. Hypothesis works first by searching the example which makes your test fail, and then on the other stage it tries to make this example as short as possible. And by providing you the shortest failing example, it helps you to find the roots of this exception. So, moving for properties in property-based testing. Property-based testing is automated testing. And first property is invariant transformation. For example, when you're checking shape of data frame, from time to time, it's not changing. The other very easy strategy is does not crash. You just run your test, and there's no way to crash it only by inputting different data. It's nice for negative testing. Very nice strategy is round trips. For example, you encode your data, your categorical features with feature encoder, and after that you want to decode it. And after decoding, the output should be as the input was. You may add, subtract, you may insert contains. There are different types of round trips strategies which you can use. And here goes the demo. About easy examples of using hypotheses.
Показываю полный, да?
Экран, да. Можно полностью экран.
Хорошо. Это вырежем.
You need to import given from hypothesis, and then there are different types of strategies. You may need integers, text, characters, one-off, and none. There are also special strategies for data science. For example, for pandas, you may import pandas series. Hypotheses create synthetic datasets for testing your functions. An example: when you are writing your tests, you may think only about the easiest examples, but you may not think about the worst cases. For example, then there are different types of variables which are broken one. And here we run does not crash strategy. We will test function encode columns with dictionary and test it on these datasets. As we can see, on first dataset it works well, but on the other fails. We have error. There are spaces in this variable. So we need to fix this thing by, for example, adding another argument, which is input value for other variables values. Now it works. We continue to check these functions, and it works well enough. But we want to test it with a hypothesis to find some corner cases. We start with writing strategy for hypothesis. We imported already series, and we check one of none or text contains these characters, and runs example. It gives us some examples, and after that we are writing this hypothesis strategy as a decorator for testing function, like this. When they are running this, hypothesis tries different examples. Tries this, this, and finds minimal falsifying example. You can see this example and then continue fixing your function until it will work well. This is workflow for writing property-based testing. Now I'll show you some other strategies in hypothesis, and also there will be example code which you can run yourself on your own project. So we start again by importing given and example. We import pandas series, text, characters, integers, and a lot more. Making small data frame for checking. And making examples of the things which can find hypotheses, like here. Just some small demonstration. You may wanna have variable with these properties. It's also possible to write. So you are wanting to check round-trip strategy. As I was mentioned, add, subtract, encode, decode. Here we will test decoding by dictionary. We'll decode column country. We are writing hypothesis strategy for checking it. And it shows us how it works. When it runs this function, it gives us some working examples, plenty of. And then finds an error. And the error is in different types of none. After finding that example, we may check it manually and fix the error. So we are making another version of a function which works well, runs hypothesis again. And there is another error with other type of none, which is none. And these are corner cases for Python. You may fix these errors until it works really nice. So I recommend you to check that code yourself. And another notebook with example for hypothesis for different strategy. We're starting it the same. And we'll test the Oracle test. Oracle test is a test strategy in which you have the longest version of function which is doing right. For example, then you are doing sorting. You may sort it a very slow way, but right, and easier to write algorithm. But you may wanna write it faster, and for checking your sorting, you may use Oracle strategy. There you compare results by two different functions which are doing the same, but different ways. There's also a nice feature in hypothesis which helps you to make printing when it has some errors. It's good for logging your variables. As you can see, it works. For Oracle strategy, we'll test that function, which returning mean for series. We're setting up strategy, running function, and it shows us the example, which is falsifying, which looks like very long example. And after the checking it manually, we can see that it may be the feature of the error of too big digit in Python. You may wanna test these things too. Other strategies you may find useful are different paths, same destination. It's better to understand via pictures. You can append digit different ways, or you may add something in the list then sort it, and in a different order. Other strategy is for making the things with fixed result. For example, you making a set from a list, and every time you make a set from a list, its shape should be the same. Or you may choose data frame columns. There can be an error if your column list, which you are making, is not distinct. The shape of data frame may change. Other strategy we were using is hard to prove, easy to verify. For example, in sorting, you sort a list, and after that you may check if list is actually sorted, like on the picture, and it helps you to write cases in which list is not sorted. And again about Oracle test, which I showed you previously. It can also helps you to measure the performance of your code, to test wherever your model works fast enough, not when you are refactoring it, for example. This is all for testing frameworks we use in our projects. And now to general rules of writing beta tests. Moving to different types of tests. There are positive tests and negative one, about which you can forget. But there are also a lot of topics to test negatively. For example, then you're raising right exceptions. For boundary cases, for which you can use hypotheses, is also very important to write tests. And positive tests are easy to write in PyTest. Rules for tests for naming and intents and spaces are the same as for general Python code. I mean pip8 and other style guides, maybe your own style guide in your own company. It's not right to overcomplicate tests, but it should be easy to read and easy to understand, not like the one in the picture. For testing, you may want to use a framework, for example, have different parts, then your given part, the counting part, and the output, but it's optional. And important point is that a good developer doesn't always mean good tester, because testing code differs a lot from ordinary production code. Of course, tests should be straightforward, but they should contain a lot of information to understand the cause of failure. Because you are running PyTest in command line and you read the test also from command line and not from test.py module. Tests also should be simple because we are not testing tests. And then tests become too big or too complicated, or maybe in the worst case too spaghetti. Maybe you should start refactoring your code, and refactoring code makes your tests easier. And the main rule for unit testing, you should test not realization, but output. These are the tests for. So, best practices in production does not work elsewhere. What are the differences between production code and testing codes, which you may find confusing? Production code is too complex to read at once, and testing code is read in command line and should be easier to read at once and understand the cause of failure. In production code, components are logical chunks which are connected, but tests are written. We are reading tests in isolation, so they should be isolated. In production code, there are a lot of abstracts which erase complexity of the whole code, but testing should maximize obviousness for their exceptions. In production code, you type the names of variables manually or semi-manually, but in testing it's all written automatically, so you may use very, very long variable names if it's needed for simplicity. In production code, magic numbers, for example, as arguments, is anti-pattern. In testing code, it may be pattern because you read your testing code in command line and it's easier to understand the testing function when it's all in one place of code. When we start using tests in our company, we find it very useful, and I think you'll find that tests are useful for your work too. I thank you for your attention, and if you have any questions related to testing in data science, I will be glad to answer you. Thank you.